On once, yeah, we're okay.
Okay. Okay, so going to talk about C++ for mobile platforms today. And again, it's not a framework or anything like that. It's just a set of tools and a workflow to kind of get this done. Okay, so just to kind of give a little bit of an agenda, I'm going to kind of go over mobile C++ and also C++, kind of give you some goods and bads and whatnot. Then I'm going to get into more architecture type things, some high-level stuff, and then get kind of deeper with some Android-specific things and how to implement it. Last thing, I will go through some additional tools. There's a lot of them. You know, kind of point out which ones I've had good luck with, bad luck, and some of my favorites. And then hopefully at the end I'll have a little bit of time to answer any questions. All right.
Sounds great.
So first, a little bit about me. I actually have a background in web development with a bit of iOS and Java experience. I got started with cross-platform C++ back in July, so I've been at it about 7 months now. And currently, kind of my two things out in the world right now are the tutorial site that you heard about, mobile C++ tutorials. There's a couple different tutorials on there about what I'm about to describe to you. One's kind of a really simple hello world example, and another one actually uses a database. The other thing I've got going on, I just recently completed a cross-platform TV app. It's available on Apple TV, Android TV, and Fire TV. Fire TV also runs on Android, so it worked out pretty well. All right. So first, to kind of go over C++ a little bit, what it is and kind of what it's got going on. So what is it? It's been around a long time.
Bring it all the way down. It's still broken.
It was developed by Bjorn Sustrup.
Sorry, Stephen, give me 1 second.
Okay. That's still too loud.
Oh, it's not you that's too loud. It's the speakers. Just we can't adjust the volume in the other room, so there's not much we can do. So you're good. Please continue.
Okay. All right. So it's been around a while, since 1983. It was originally an extension of the C language. So the plus plus is actually like numerical incrementation. It's used in surprisingly a lot of places, from robotics to gaming. It's in mobile apps, obviously. So it's kind of everywhere. And one thing it's known for is just really high performance. So you can kind of get right down into managing memory and all that kind of stuff and optimize it any way you want. All right. So let's start with the good things. What are some good things about using C++ for mobile? It's been around a long time, and that's good. There's plenty of information on the internet. If you run into error message or whatnot, you can look it up. There's tons and tons of libraries available. OpenCV is like a computer vision library. Boost is a collection of libraries that I'll go into a little bit more detail later. It's great for apps that have a lot of use, like outside of the UI, like talking to a database, talking to an API, anything like that. It's good for if you've got a new project, be it a prototype or an MVP, or if you're starting from scratch, it might be a good idea. One cool thing that I've been doing is unit testing. So if you have your code all in C++ and you unit test the C++, and you're adding features in the C++, you've kind of already done a bit of QA ahead of time on your Android app and your iPhone app. So that's kind of nice. So one thing it does do well, it's kind of a good thing and a bad thing. So when you're doing this, you're going to be using like the native iPhone table layout and the native Android table layout. which is good because Apple has made this optimized for their hardware and that kind of thing. So you have to build it twice, but the performance might be a little bit better. It works on TVs. The reason I have this on here is because there are some cross-platform solutions that rely on web views, which will not work on TVs. Apple TV, for instance, you can't even instantiate a web view. It's known for fast performance, and it's free. It's open source. Everything we're going to talk about today is pretty much free to use, outside of paying your kind of yearly dues to Apple and Android, but you're probably going to have to do that on any other platform anyway. It's cool because you can be wherever you need to be on day one. You don't have to wait on another layer of another framework or another platform to kind of implement new features like, a watch kit or health kit or anything like that, or Android Wear. You can kind of just go straight there and be there. All right, so I'm definitely not going to sugarcoat this. There's definitely some disadvantages, so let's go through some. It's been around a long time, which can be bad. There's a lot of out-of-date information on the internet, and when you're trying to find an answer, you'll probably find 7 or 8 different ways, several different libraries that can do it, and it can be hard to determine what's kind of the best way to do it. It doesn't make a whole lot of sense if your app is mostly UI, because there's not really a way in C++ to build and design a UI, nor would you really want to do that. So you're going to have to build the UI in Android and Apple or iOS, but it's not as bad as it sounds, because if you take out a lot of the other logic in the app, connecting buttons and that sort of thing isn't as much work as it might seem like. It can be difficult to migrate kind of legacy code or existing apps. You can sort of do it in pieces. Take an API here, implement it in C++, and then pass it on to iPhone and Android, that kind of thing. But taking a large legacy code base and doing this with it might not be such a good idea. So I came from web development world, and there was a bit of a learning curve here. And depending on what your programming background is, if you've dealt with memory and stuff like that, you'll be in a better place. But kind of coming from web development or potentially native app development, it could be a little bizarre. There is a lot going on with this. Again, it's not kind of one framework. There's at least 5 different languages, several different command line tools, extensions to your native development environments. So it can be a little overwhelming. It's not exactly an easy sell to the people that matter, your clients and your stakeholders. You kind of have to have just someone who's gung-ho about it that can make these decisions. Kind of already mentioned this. You have to build the UI on each platform. Okay, so just to kind of get a vote of confidence, I wanted to show you who all is doing this. On the top there, Dropbox is actually the company that sort of pioneered what I'm going to talk to you about today. Their utility Genie kind of makes things a lot simpler for this. And all these other companies are kind of regular appearances in this Slack channel at the bottom, mobilecpp.slack.com. There's developers from all these companies, sharing ideas, answering questions, and that kind of thing. So there is kind of a thriving community happening. Okay, so let's talk about some architecture. The background picture actually kind of represents what we're after, right? So on one side of the wall, we're going to have our C++. The other side of the wall, we're going to have our native code. And that tunnel is going to be how they talk to each other. So this is kind of a high-level diagram of what it's going to look like. We have another analogy is comparing it to web development, the back-end code with your database and all that, and the front-end code with your UI. So if you think about it that way, C++ will be our back-end, doing a lot of the business logic and that kind of thing. And Java and Objective-C will be our front-end. And between those things, we have what's known as two bridge languages, JNI for Java and Objective-C++ for Objective-C. So I know you can't see me right now, but I can see you guys. Raise your hand if you've ever done anything with JNI. Okay, I see a couple people. Raise your hand if that was a good experience for you.
0.
Okay, I didn't think so. Yeah, these bridge languages are not fun. They're really gross looking when you actually have to type it all out. They're really hard to troubleshoot. Like even getting error messages at all can be a problem. They're not very well documented, and you're not going to find an IDE with all nice syntax highlighting and that kind of thing. So this is where our friend Jeannie is going to help us. So a couple years ago, I think two Septembers ago, Dropbox released their tool Genie open source. And what Genie does for us is it generates all that bridge code that we don't ever want to see. So our little diagram over to the right, we can get rid of JNI and get rid of Objective-C++. We're still using it, but we don't have to edit it. We don't have to ever even see it. We don't have to know it's there. How it works is you pass basically a configuration file to it. It's called an IDL file, stands for Interface Definition Language. It looks a little bit like JSON. It's not, but it feels like it. And you can give it records for data. You can give it enumerations for an enumeration type. You can give it interfaces, an object with a bunch of methods. There's a few other things you can send to it, but those are kind of the main ones. So it'll take that configuration and it'll generate all this code for you, all the bridge code, and so generates all the bridge code, JNI and Objective-C++, and it'll also generate interfaces for the other 3 languages. So it'll give you a C++ file that your C++ developer can then implement. It'll give you a Java file that your Java developer can implement, and then it'll give you an Objective-C file that your iOS developer can implement. All right, so now we're going to get a little bit more code heavy. I'm going to walk through sort of the both sides of the wall. The one side is going to be the C++ side, and the other side is going to be Java. I'm not going to go into iOS for this particular presentation, but the iOS side would look much like the Java side. So first step on the C++ side is that IDL file I was talking about. So this is just a really simple interface. It's got a create method that returns its own type, much like a singleton would. And it has one method, get hello world, returns a string. Pretty simple. So we write this configuration file, and then we run Genie, which you run on the command line. You tell it where to find the configuration, and it will generate all these, all the different language bridge code and interfaces I was talking about. So on the C++ side of things, it will give us an interface. So you can see it's just one little class. If you see the keyword virtual, that's basically C++'s way of making an interface. So another class would then implement these methods. So then we get to our handwritten C++. There's a header file and the CPP file where we implement all the things that we outlined in our configuration. Okay, so now let's look at the Java side of things. Again, we start with that same IDL file. We run it through Genie, and Genie will give us our bridge. I didn't even want to show you guys what that looks like, but just rest assured those files are not fun to even look at. Then from there, Genie also gives us a Java file. I'm not sure if interface is the right word here because we actually instantiate this directly from Java rather than having to implement all the methods. It kind of does that for us as well. And then finally, in our native code, in our main activity or wherever you like, you would just instantiate it and call methods on it. So that's kind of what that looks like. That was fast. Does anyone have questions or anything? Okay, gonna keep going. Okay, so we kind of went over pretty deep into Genie. I'm going to outline a few of the other tools that are available to getting C++ on your phones. So these are all going to be specific to Android. Again, I'm not really covering a whole lot of iOS in this talk, but there are other tools for iOS as well. So one thing we're going to need to do is build libraries. This is so we can have a library shared in either multiple apps or between just to package up all the files so that they know where all their Java packages and that kind of thing are. So several different ways to do that, and I've ranked them with smiley faces. So the first one is JIP. It's a project by Google called Generate Your Projects. And I put this first because you're going to see it. If you pursue this, you're going to find it. The Genie example uses JIP. There's a library called MX3. It uses JIP. My tutorials use JIP. It's everywhere, but it's kind of terrible. It no longer supports Android. You actually have to revert to an old commit to get support for Android. And at the end of the day, you still have to write make files and JIP files. So I'm not a huge fan of JIP, and I'm trying to get away from it. CMake. CMake is kind of like the proper way to do things, but it's a little bit more intense configuration-wise and that kind of thing. And it's really, really good at making reusable libraries. So if you're getting started, I would definitely go that route instead of JIP. Finally, this is what I've been doing lately, is the experimental Gradle plugin for Android Studio. You can basically now, instead of even messing with makefiles or anything, you can just tell Gradle where to find all your JNI code, all your C++ code, and all your Java code, and it will build the library itself. When you publish to Android with C++ or C, it basically bundles everything into a library already. So this is kind of just a way to get deeper into that. I find it to be a little bit faster and easier to deal with. So it gets a smiley face too. So NDK. Obviously there's the Android NDK. You're gonna have to have an NDK to talk to C++ at all. Like Android won't even know how to talk to C++ without an NDK. So the first option is Android's NDK, but it gets not a frowny face, but a not happy face either. The reason being it has several bugs. Android's libc library, also known as Bionic, has bugs. It's also missing a lot of things from C++, things you would definitely need, like starting new threads and that kind of thing. These are normally in the standard library, but for whatever reason they're missing on Android. An alternative is an NDK called Kristax. I'm not exactly sure how to say it, but they've fixed all the bugs. They've added all the support that we need to do what we want to do. So I'll go into that a little bit later also. So another kind of tool at our disposal is Boost. Boost is a collection of libraries that do everything you could possibly imagine. And it's cool because they are peer-reviewed by the community. So you know that you're not just downloading random JavaScript libraries that are going to crash your app. It's all peer-reviewed. It's all very stable. This is kind of like the area where libraries go before they're integrated into the standard library. So the C++ standard library is upgraded every few years. There's C++ 11 that was released in 2011. Right now it's 14, which was released in 2014. And there's another one coming up in 2017. So about every 3 years, they incorporate some of these Boost libraries and release a new standard. It can be difficult to kind of get this together, so I wanted to throw out a few links. First one is a script for OS X and iOS that will download Boost, build all the libraries with the correct architectures, and you can just drop it in your Xcode project. Unfortunately, it didn't have tvOS on there, so here's another link, a fairly recent pre-compiled Boost library for tvOS. And finally, that the NDK I mentioned in the other slide, Christex, actually comes with Boost. So that's kind of a little shortcut to get that done. So to go into a little bit more about that NDK, it's at christex.net. I just didn't believe it when I found it. You basically just don't use the Android NDK and you use this instead. It already includes Boost, so that's a bonus. It has all the support you need for C++ 11 and C++ 14. It's got a lot of the missing elements that I was speaking of, like the thread and standard mutex, that kind of thing, that you're probably going to need. And also kind of, it has more recent compilers, and again, it fixes bugs in the Android libc. Okay, so that's the bulk of everything I've got. Wanted to give you a few links in case you are interested. At the top there are 2 repositories that you might want to check out. One is Genie itself, which has an example. You can compile that and publish it to your phones. The other one is MX3. MX3 hasn't been updated in a while, but it is a pretty decent example of how to do this. Second link, my website with some tutorials. Check it out if you like. The third link is the Slack channel that I already mentioned. Pretty thriving community there, questions and answers. There's some questions and answers going on GitHub or Stack Overflow, but you get a lot faster response and potentially better response on the Slack channel. And finally, CPPCon. I actually went there last year, and I have to say it was the best conference I've ever been to, which I learned a lot. There was tons of smart people there, and it was all about code too. There was very little like marketing kind of things. I don't know. It was a really fun experience, so I thought I'd just throw that out there. Finally, if you'd like to know more, feel free to hit me up. Here's my email. I'm also on all the normal places: Twitter, LinkedIn, GitHub, Stack Overflow. Okay, so those are all my slides. Does anyone have any questions for me?
How do you handle type transfer between like C++ and Java? I guess like
hang on one second. How do you handle type transference between C++ and Java?
Okay, so that's actually one thing that Genie helps us with. Again, I said enumerations, interfaces, and records. There are a few other types that it'll do. Not all Java types are supported, but that is one thing that Genie kind of handles for us. So that's kind of nice. As to the magic of how that happens, you have to look at the source of Genie.
Network communication. How do you handle like difference between like iOS's session and Android's service downloading? Does that make sense?
If you can hear. Can you hear him?
Yeah. You said networking, right?
Yeah.
Yeah.
Downloading. You can. So there's 2 ways to do that. I didn't go over this in the slides, but so the communication between C++ and the native is 2-way. So if you have a very particular need for Android-specific downloading and iPhone-specific downloading, streaming, or whatever, you can actually call back up into the native layer. So that interface you can have you outload the C++ side, and then you have a separate interface for you'll kind of tag it as Objective-C and Java. And then you implement both Java and Objective-C classes for that. So, and that can be anything. That can be networking, that can be the GPS, that can be the camera, anything that you might have to go back to the native layer for. Does that make sense? You can also do networking in C++, but it's a little bit more complicated.
So you prefer going through the platform and feeding into C++?
Actually, so I've only done this for an analytics library that I built. It was kind of a cross-platform implementation of Google Analytics, and I did do it in C++. So, but that was really not complicated at all. That was just loading pixels and not even looking at the response. So, more complicated things, you might want to go back to the native layer.
Okay. Well, thank you very much, Stephen. All right. Thanks very much. I'll email you. I've got some our hosts giving you this $25 gift card as a thank you. So thank you for your time very much.
Yeah. Bye, guys. It was nice meeting you.
See ya.